the trapezoid representing initial velocity, final velocity, and time interval, corresponding to the trapezoids that we saw in the graph, gives us a lot of information, and also the picture helps us keep straight how we do our calculations. For example, the slope of this graph is the rise divided by the run. The rise of the graph is the change in velocity. The run is the change in the time, the clock time, the time interval, the length of time over which the velocity changes by this amount. We see that the change in velocity is a difference between the initial and the final velocity. We add this to this and we get this. Contrast that with what happens when we calculate the area of the trapezoid. To calculate the area, we take the average altitude, which in this case represents the average velocity, and we multiply that by the time interval. That corresponds to the area under this rectangle, which of course is identical to the area of the trapezoid, because this triangle and this triangle are similar. We could just cut this triangle out, turn it upside down, flip it over, put it here. And we would have the rectangle. So the area is obviously identical. Okay, when we calculate the average velocity, we add the initial and final velocities and then divide by 2. There's a lot of confusion. Often people will subtract the two velocities and divide by 2. Well, if you think about the picture, subtracting the two velocities is going to give you this change in velocity here. And there's no sense in dividing that by 2, so that would be a nonsensical calculation. Or some people, in calculating the slope, will add the two velocities. It's a little confusing because when you calculate the average to get the area, you have to add the velocities. When you calculate the change of velocity to get the acceleration, you have to subtract the velocities. If you just think in terms of common sense and make sure that every calculation you do is consistent with this picture, you won't make any errors.